All right, and the last thing we'll throw into this mix, just to kind of get a bunch of things out there all at once, is the average value of a function. All right, so you already know how to take an average. If you had to average out your test scores, you add up all your test scores and divide by how many there were. All right, that kind of definition doesn't make sense anymore when you're talking about a continuous amount of values, because an infinite number of things you have to add. So you have to divide by an infinite number. So you have an infinite number on the top, infinite number on the bottom. What exactly should the average be? All right, so we're gonna have to do the average in a slightly different way. All right, and the formula ends up being this. So the average value ends up being kind of the distance from B to A. So that's kind of what we were using as the number of values. That would be the bottom of your average formula. And then for the top, the kind of adding up everything, we're gonna use the area of under that curve. So we're gonna take the area under that curve, divide it by kind of the width of that area, and that'll give us the average value. All right, so right now, kind of just a formula you have to memorize in a way, but it makes sense that this is kind of adding up all the values, finding area, and you divide by how wide it is. That should kind of cancel out and give you the average value. And we'll just do one quick example. I have y equals 2x plus 4. We're going to find the average value from -2 to 6. So the first thing we have to do is graph it, because right now we have to use a graph to find our area. All right, so 2x plus 4 is going to have a y-intercept at 4 and a slope of 2, so 2 over 1. And we connect that to make our line. And then we have to find this area, so -2 to 6. All right, finding this area here. All right, my graph's not exactly right because when I plug in -2 into this function, I get 0. So this is actually at the the x-axis. So it looks more like this. So that's the area we're trying to find, and just being a big triangle. So the width of this triangle is from -2 to 8, -2 to 6, that is 8. The height of the triangle is when I plug 6 into my function, is 16. So the whole area of this is 8 times 16 divided by 2. The whole area is going to be 64. So to find the average value, I take the area and divide it by the distance between my endpoints. So the distance from 6 to -2, we actually already said is 8. And I don't know why I wrote 84 instead of 64. And 64 divided by 8, so the average value is 8. So at the beginning of this, we get numbers that are less than 8. At the end, we get numbers that are bigger than 8. But if you were to kind of average all these, move this part down, move this part up, it would end up that just at 8 would be the average value of this function. And finding the average value is useful. I just kind of know what happens most likely in most scenarios. All right, so this is hopefully a lot of little short videos. We'll put it all together in practice in class. For the main things, we have this new integral sign, which is basically just a shorthand for saying find the area under whatever function you have here. And for right now, just know that we're basically gonna have to use geometry, circles, triangles, rectangles, all that to find these areas. And the other major thing we learned is if you have an area below the x-axis, these are gonna be negative areas if you're using your integral sign. All right, so those are the main important parts, are kind of split up into different pieces.